Welcome to the demonstration of OpenL Tablets tables. We'll be discussing how to develop a table using the OpenL syntax and viewing demonstrations through Web Studio. If you've not viewed the Web Studio Basics video yet, you should do that prior to reviewing this video. The first thing you need to know is that everything is in a table. Everything is formatted inside of a table, whether it's a listing of related data or some type of rule or function that you're developing. You must understand how OpenL recognizes tables and their syntax. Tables are the foundation used for creating rules projects. Whether that rules project is for creating a rating engine, or maybe even for claims when you're creating fraud detection algorithms. From a business rules development perspective, you create rules inside of tables. You also will set up your data inside of tables. Tables are either developed or accessible using Microsoft Excel or OpenL Tablets Web Studio. When using Excel, it's important that you understand that you need to use the syntax and guidelines that OpenL requires, and not how you might be used to writing your syntax in Excel formulas, because that's the syntax that Excel recognizes. While they're similar, it's important that you know what the differences are so OpenL can run your rules project and data correctly. OpenL Tablets recognizes specific keywords that define the type of processing that will occur with the data that's found on the table. Also, tables that perform different rules must be separated by either an empty column or row. So rules with different goals that have different tables need to be separated by one blank row or one blank column so OpenL knows that they're two separate tables. As an analyst, it's imperative that you understand the syntax that's required for OpenL to recognize your rules and tables, and this is what we're going to discuss right now. Here we're looking at a matrix of the types of tables that are supported by OpenL. We're going to discuss some of them on here, but not all of them in this module. You should reference the OpenL reference guide for a complete listing and description of all table types. So let's get started with the first type of table, which is a decision table. And the syntax or key word that OpenL is looking for is rules. So really this is rules development done inside of a decision table, and we'll see examples of all of these. But a decision table is where you can define conditions, and if those conditions are met, then you can have either actions performed or you could return a specific value. These are the tables that really execute the logic that you're defining. Then we have another type of decision table, which is called a SimpleRules table, or that's the syntax is SimpleRules, and this is actually the most common table created in OpenL. You can actually create this to retrieve values associated with conditions that match to true against data that's passed into it. So you'll set up your decision table, you'll put conditions in, you'll pass data into it, and when the conditions are met, it will then return a specific value. And we'll talk about that later. And then we have a third type of decision table, which is called a simple lookup table. And you can create this to retrieve values associated with conditions that match true to the data passed in it, just like the SimpleRules. But the main difference with the simple lookup table compared to the SimpleRules table is that you can actually display or lay out your conditions both vertically and horizontally with a simple lookup, where in SimpleRules you just lay out your conditions vertically. Then we have the spreadsheet type of table, and this is a really cool table where you can design all sorts of formulas and perform calls, and it can be a almost matrix of different formulas that calculate value, and that you can reference them later from different worksheets or different tables as well. And we're describing that one in this module. We have data tables that you can create that stores data, listings of data that you would like to use in your workbook, in some of your decision tables or rules. Also, data tables can be used for testing the capturing of data. So it's a set of data that you'll be using. Then you have data types of tables, and again the keyword is data type, and this is where you can actually define groups of data to become a custom data structure. So you can use this data type to pass a set of defined data into tables to be processed like you would pass parameters. We have test tables. The syntax again, OpenL is looking for the word test in a table, and it's here where you can enter test data to be run against your decision tables or whatever other type of tables that you create your rules for. But not only do you enter your test data, the expected results as well are in your test tables, because then when you run your test data and get your results, it will also compare the expected results in this table and see if you are getting your expected results when you run your rules or you're not, so you know where you need to fix your problems. We also have run tables that can call a decision table or method table and provides input values for each individual call. It's kind of similar to the test table, except they're not performing any checks of what the return value would be. Then you have the column match type table, which allows you to create tables that either match, score, or weight data. We have properties tables where you can define properties at a module or category level. There's 3 different levels that you can define properties, and maybe properties are a description or a version number or something important to identify your table. You can identify them at the table level, the category level, and the module level, and that'll make a little bit more sense as we go forward. Then we have a configuration type of table, but the keyword or syntax that OpenL is expecting is the word environment. This table is where you can define specific types of properties, and one example is that you can link, let's say, different projects or different workbooks together inside of OpenL, and you would actually define that dependency or those links in this type of environment table, and you'll see that later. We have a T-basic table that allows you to use complex logic such as loops, setting variables, creating if statements, checks, switches, stepping through logic. So that's for your real advanced type of rule development using programming concepts. We have method tables, and we're not going to be talking about those, but this is a Java-based and written program. So this table executes Java methods, and methods are functions that execute logic using Java. But before we get into the tables, let's just talk about the structure a little bit more. So first we need to know how to create a table using the table type keywords that we just discussed. So here on this slide, I have a listing from the reference documentation of the keywords that OpenL accepts and recognizes. Then I have an example of a table in a Microsoft Excel worksheet, and then that exact same table opening up in Web Studio. In order for OpenL to recognize a table type, it must encounter the table type keyword in the first cell of a table. And in that first cell, you should actually merge all the cells for the entire length of the table. You're then going to call this the table header. So in this screenshot, we have a simple lookup type of table created. You'll see that it has a bunch of rule logic underneath of it, but the header starts with simple lookup. If I went into Web Studio and opened up that same exact table, just viewing it through Web Studio, you'll see the simple lookup table just as you see it as in Excel. You could update the table in Web Studio or Excel. It is good to note, though, if you are doing updating in Excel, you'll need to do importing and exporting of that workbook or module and review the Web Basics video if you don't understand how to actually do that. So getting deeper into table syntax, you'll notice that the syntax of tables and how they are created in Microsoft Excel is extremely important. If OpenL doesn't recognize a table's header by a keyword, or if some syntax is incorrect, it's either going to provide you, the user, with very descriptive error messages to help you fix your syntax, or if it's a table that you wanted to keep in there, it's just going to allow you to keep your table with your content in it, but it's not going to actually do any processing on it. Also, depending on the type of table you create, the header line must include this specific syntax. It is recommended that when a table header is created that you merge all the cells across the header for the entire table, as I discussed prior. In the example above, the first word in red must be a table keyword. Then, if the table is supposed to return a value, you must define the data type of the value to be returned. Data types such as string, integer, and other data types, which we'll discuss all the data types OpenL allows in a slide coming up. Then you must name the table. And it's best if you use a unique name. This is the name that you're going to use to call the table from another table or formula to run or execute its logic. So you really should name it in an identifying proper way. And when I say the word call, this means to actually run a table, which includes passing data into that table via its parameters. If you're familiar with Microsoft's processing of functions, this is the same as a function call, but the table is the function which you're calling. Parameters are used as containers to pass data into the table that will be used to check the conditions or be used in a formula that you've designed. The term parameter and its syntax here is related to computer science. A parameter will hold a value that's passed and then will be used inside the table to check its values against the conditions in the table. A parameter must have a data type, as OpenL Tablets will check to make sure that the data that was passed into the parameter is of the right data type. If not, you will receive an error. A parameter's name can also be used inside the table to write formulas, or as we call them, expressions. A table may have many parameters passed to it, even though in the above example you only see one that's displayed. This data in the parameters is then going to be checked against the conditions that you enter. In this screenshot over here, this row is for information purposes only, as it tells whomever is using this table, like an analyst, what's stored in these columns. The first column holds condition values that the parameter is checking. If the parameter and the condition are equal, OpenL will resolve that rule to true and return whatever value is in the associated return value column of that row. Now that we've discussed the table header, the next section, which is optional, is to define properties. Properties can be defined containing information about the table. Table properties are displayed in the section which goes immediately after the table header and before the other table contents. The properties section is optional and can be omitted in the table. The first cell in the properties row contains the keyword properties, and it is merged across all the cells in the column if more than one property is defined. It's important to make sure that you merge properly. The number of rows in the properties section is equal to the number of properties defined for the table. Each row in this section contains a pair, which is the property name and the property value. Note that tables can have properties, but also there is a OpenL table type, which is called properties. And this is different. That's actually a specific table which will define properties for a whole category or a whole module. This property at this level is just specific to this table, and because properties can be inherited at this level, if properties are set, they will define the property at that table and override any other properties that might be set at a category or module level. Now we're going to discuss one of the most important types of table in OpenL, which is the decision table. And you can see next to it that the word rules is there. And really this is a business rules management system, and you can develop rules to execute your logic. And that's really what these decision tables that you create represent. A decision table gives you a way to model complex logic inside of Excel tables or within tables inside of Web Studio. What you can do is write conditional rules which will either perform actions or return a value. There are different types of decision tables that you can create depending on your requirements. It is important to understand how OpenL needs you to structure these tables so we can properly identify the table type, the name of the table, the return value for the table and its associated data type, any parameters that you might pass into the table that you're going to use with that conditional logic that you're going to write inside of the table, any actions that are going to be performed or any returns. You have to use the correct syntax for all of this when writing your algorithms and setting up your rule. Because there are many different ways to structure tables and write algorithms, you're going to need to use the OpenL reference guide. We're going to discuss a lot and give you a good foundation today, but you'll want to use that reference guide later when writing your rules, as this guide has all the syntax and explanations of available options. So lastly, in OpenL, a rule is a logical statement consisting of conditions and actions. Rules can be called sending parameter data to check for conditional logic that results in a true expression. Once OpenL finds the true expressions it requires, it can then either execute a specific action or return a value to whatever the calling table or rule was. So here's our first example of a simple rules table that should be used when you need to return a single value which is determined by matching a parameter value and a conditional value. So the simple rules table will list conditions and then a result and values for both in the rows directly below their columns. The parameters for the table are used in the order that they come in to check the conditions in each column. Each column of each row is checked, looking for a match that is true. The first true result for all condition columns in a row will then return the value in that associated row of the return column. So let's look at this example of a simple rule table. The first thing you're going to do is put the keyword simple rules. Then you're going to define the return data type. It is required that if you're going to return a value by executing this rule, that you data type or list or define the data type of that value that's going to be returned. Then you're going to give the table a unique name, and this name is what you will use to call this table from other tables, or the name you'll use to execute the logic in this table. Then you have in parentheses the names of the parameters that you're going to use to pass data into this table to execute the logic with. Now, each one of your parameters must also have a data type defined for it. So the table knows what type of data is expecting, and knows what to do with it, like how to compare the parameter data with the condition data. You'll note that your parameter data will have to have the same data type as your condition data as well. And you can see below, we start to have the condition columns. This first row in yellow is just a descriptive name that a business analyst or anyone would put in so the table is readable. These are not actually conditions that OpenL is checking against. The next row, you're actually putting in values for your conditions. Now, I know underneath of body type, the first conditional value we have is convertible. So your parameter body type, the data that comes in, will be checked against convertible, and convertible is a string type, and so should be the data coming in through body type. Now our next condition is airbags, yet this is an empty cell. OpenL will resolve this as true, so this will be true. So if OpenL finds that the body type is convertible, that will result in true. If airbag comes in, it doesn't matter for this record, that's going to result in true. And if the last condition, roll bar, comes in as no, then each one of these conditions has resulted in true, and then the injury rating of extremely high would be returned for this table. Notice that the roll bar is no for a conditional value, and in the parameter it's expecting a Boolean, which is yes or no. That last column, you'll always have one last column in a SimpleRule's decision table, which is the return column and has the return values. Those return values must be the same data type as expected for the data type that you listed in the header. That's a basic structure for a SimpleRules table, and you'll note that it doesn't require a lot of syntax that you're going to have to enter for more complex rules. You're not actually required to use syntax that identifies conditions, returns, and data typing. It's important to note, though, even though you're not doing this data typing for the columns of the conditions or the return values that you'll see later, you still need to make sure that the same data type for the input parameters and the return value, which you defined in the header, are the same data type of the conditional values and the return values. And lastly, you just don't have to write a single condition for matching in a SimpleRule decision table, but you can use ranges and arrays. And what this means, you can write either a range of values or an array of values as a condition value, and then OpenL Tablets will check whether the corresponding input parameter falls into the specified range of condition values as well. So you can also use ranges and arrays with your simple decision tables. So now we're going to do a demonstration of a SimpleRules table. I'm going to go to the repository view. I'm then going to select Create Project. In the Create Project window, we have some templates that we can use. We're going to actually use Tutorial 1, Introduction to Decision Tables. I'm going to select the Create button, and you've noticed that it's created the project for me. I'm now going to go over to the Rules Editor view because you can see the project it created is in the editing status. So all I need to do now is go back into the Rules Editor, and I can start by selecting on Tutorial 1, Introduction to Decision Tables module. And I'm going to expand all of the decision table listing so I can see the different decision tables that we have. And actually, Driver Premium 3 is a SimpleRules table. I'm going to select on that table. It's going to open up here. You're going to see that we have the SimpleRules keyword. We have a double value as the return data type. We have driver premium 3. That's the name of the table. Then we have parameters that this table accepts, which are driver age and driver marital status. Then we have the conditions. We have values for driver age. We have young driver, senior driver, standard driver. For marital status, we have married, single. We also have a blank value, so no matter what comes through for this parameter, that's going to actually resolve as true. And then we have the return value, which is the premium increase. So if I actually run, I will run and put in a driver age of young driver, and then I'll put in single. I'll hit the return key and I get 720 as my result. Now I'm going to go back to the table. You can see young driver, that's single. The premium that's to be returned is 720. But I'm going to then run some data for this standard driver so you can see what happens if I run and I put standard and then I put single here and I hit enter. It's going to return 500. If I go back, I notice that this was blank, so it wouldn't matter if married or single came in through the parameter as a value. It's always going to return 500. So this is an example of a SimpleRules table. Now we're going to demonstrate how easy it is to create a SimpleRules table using the OpenL wizard functionality. So now we're going to demonstrate how easy it is to create a SimpleRules table using Web Studio. I actually put the project called Tutorial 1 Introduction to Decision Tables in the editing status, and I found this project on the OpenL website, and it helps you learn about decision tables. I'll select on the main module, and then for training purposes, I'm going to expand the decision folder. So you can see when we create this table how it appears in this folder. I'm going to select the Create Table button. So now I have to select a table type, and I'm going to go down and select the SimpleRules table. I'll select Next. Then it's going to ask me for the name of the table, and I'm just going to put driver premium example. And then it's going to ask me for a return value type, which I'm going to put as a double value. Then it's going to ask for an input parameter. I'll select input parameter button, and then what type of input, this is the data type that the input parameter is going to be. And I'm going to select string. And then I'm going to put marital status for the name. And actually we begin the names with a small letter. If this was going to be an array, like we saw in another example when we had arrays of vehicles or policies, I could select this checkbox, but it's not going to be an array for this demonstration. Then I can select the next, and you can see it's that easy. Web Studio has created the beginning of the table for me with the correct syntax. You can see the keyword SimpleRules, my return data type is double value, the name of my table, driver premium example, and then the data type of my incoming parameter. My parameter name is marital status. It also creates the condition column for me called marital status, which will check the marital status incoming parameter, the values there. And then I also have the return column. So you see below that there's tips. I either use my left mouse button to actually edit the values in cells of this table, or I use my right mouse button to perform actions. We have actions available to us in the right menu options, which are to add a rule, delete a rule, insert a condition, delete a condition, or add or remove properties. So I'm going to right click, I'm going to select Add Rule, and you can see how a new row is now populated for me. I'll use my left button from my mouse to actually begin to edit that cell, which I'm going to add a value for marital status, which I'm going to write as single. I then used my left mouse button again and clicked in the return first cell value. And I typed in 10. So now I'm actually going to right click again in the return value, and I'm going to select Add Rule again. I'm going to type in married. I'm going to type in the return value for married is going to be 20. And now I'm done. I'm going to select the next button. So now it's going to ask a destination of where I want to create that table. So you're just going to use the default main. And then under categories, I can select an existing category that's in this project. And again, remember, those are your worksheets in your workbook that's associated with this module. So for training purposes, I'm just going to put it in the step 2 category. I could create a new category and a new worksheet, but I'm not going to. Then I'm going to select Save. And now you can see it's created the table for me with values in it. And then also on the left-hand side, you can see the table in the decision folder. I'm actually going to run this table so I can demonstrate this to you. I'll type in single. I'll select Run, and you can see the result is 10. That concludes the demonstration of how to create a simple rules table using the wizard. At this point in the presentation, there might be a need for some clarification about how data is passed and rules get executed. What you're seeing here is a illustration of a oversimplified view of how data is processed. In the blue boxes, we have 2 separate applications. We have the outside application, which we're going to say in our example is EIS, and we'll use Policy Core as our product or our outside application. And then we also have OpenL in the second blue box. In the initial step, a user of an application, which in this example is Policy Core, will enter in all of the required data needed to quote a policy. So the user will have entered in all the rating criteria such as age, gender, location, risk, coverage, and whatever required data is needed to run this rules project for rating. After they enter the data, they then select either a submit or a quote button or some type of button that triggers a web service call and sends a message to the OpenL rule project you designed. In this message is all the data that the user entered for quoting the policy. So initially, OpenL will perform some validation on that data to make sure that the data that was sent was either all there or correct. If not, the user of Policy Core is going to receive an error because OpenL did not get this data that it needs to run your rating project. So if it does get all the data that it needs, then your rating plan will start to execute. And usually the first table to be executed is a spreadsheet table, which we're going to discuss later. But the spreadsheet table allows you to create various steps with formulas that actually call other tables to be executed or consists of formulas that you've written in our expression language. After all of your formulas have run and your rating project will return the values that you're looking for, and they might be premium coverages that go back to the policy core application via a message again. So that really summarizes at a very high level how the data is passed from Policy Core into OpenL, and then how OpenL takes that data and uses different types of tables to calculate formulas and check conditions and retrieve values. So your spreadsheet table might call all sorts of different tables that you've created in your module to perform different functions. And they can check conditions against the data which was passed in via that message that we talked about. And then it can also retrieve factors that you'll use in later calculations. You might get a factor for location or construction. There's lots of different factors that you might need to get via some decision tables and then pull back into your formula that's on your spreadsheet. So there's an order to which your tables are executed that you might define in your spreadsheet table. And there's also an order to which the data is passed into the tables via parameters. So it's good to know how to pass parameters into your tables. So now this is a different type of table. This is called a rule decision table, and you're going to use this when you have more complex rules than will be allowed by using the simple rules decision table. You're first really going to need to understand the structure and the syntax of this table in order for the rule to process correctly. So we'll start off by talking about the header. The header is going to use the keyword rules. Then you're going to define the data type for the return value that you're expecting. Then you're going to name the table. And again, this is when you actually call this table or go to run it or have it processed or executed. This is the name that you're going to use. It's also called the table name. And then lastly, in the header, we have in parentheses any parameters that you're going to pass in. And first you need to define the data type of the parameter that's going to be passed in, and then the actual name of the parameter will be listed. The next row is for your optional properties, which we're not going to talk about. But then you have some required syntax that you need to understand. So we're going to start defining the conditions of this table. So condition number 1 must, in the column, in its row, have C1 listed for the first condition. And if you have a secondary condition, then in the next column, you need to put C2. And if you had a third condition, it would be C3. And you would keep this pattern up for all the conditions that you're going to check for your rule. Then you can have a return value column, but you need to use the syntax RET1. That's standing for your return value, the first return value. You could have multiple return columns and name them RET2 and RET3 and so forth, but it's important to understand, though, only the first not blank value will be returned as a result, and not all of them from the executed rule row. So after you've put in the correct syntax to identify conditions and return values, the next row is where you could write your conditional expression. This is the logic that you might run during checking this condition. In the example, condition 1's expression is min is less than or equal to hour. Well, min is going to be defined below in that conditional column. You can see we have a listing of values, and actually underneath in the green row we're saying that min is of integer type and it's listed below. Now hour is actually a parameter that's coming into this table, so that's being passed into the table. So then what will happen is OpenL will go through each one of those min rows and use the value in there and the value that came in from hour, and then run the expressional condition. And what it's looking for is if that condition resolves to true. Is min less than or equal to the hour value that came in? So it's going to look for true in the first condition and in the second condition. And when it finds true in both columns for a row, it's then going to go to the return column. It's going to take the value that's listed in the return column. It then has another expression that is going to be used for the return. So it's going to take the value, it's going to add the word world to it, and then it's going to return either good morning or good afternoon or good evening world through to greeting, because that's the return. So in an example, let's say in a spreadsheet formula there was a call to this table called greeting, and the parameter that was passed into greeting was the number 15, which might have been calculated from something else, but let's just say it's the number 15. So greeting starts to execute and uses 15 for the hour. Processing starts to go through condition column 1 using 15 as the hour, and then tries to go through and find a min where hour is less than or greater than 15. So for the first row, it's going to come to be true. It's going to resolve as true. The second row is going to resolve as true as well. But if you go over to the conditional column 2, it's going to take hour, and it wants to see if the max is greater than the hour. So you're going to go down, and 11 is not greater than 15. So that's going to be false. So that row is not going to execute. But 17 is greater than 15. So we had a true in conditional column 1. We have a true in conditional column 2. What's going to happen is good afternoon is going to be the return value. And that's actually going to be put into the expression that was written, which is greeting plus the word world. So the whole value that's going to be returned for the string is good afternoon world, and then that's going to be returned to whatever table performed the call. Here we're just talking about some basic rule processing concepts that you should be familiar with. So the first rule to execute in your project should contain calls to all the other rules or tables that you've created, and we talked about that, and usually it's a spreadsheet type table, which we'll get into. For your decision tables, it's a set of rules describing decision situations where the state of a number of conditions determines the execution of a set of actions or a return value. So rules inside your decision tables are processed from top to bottom, one by one. A rule is only executed when all of the conditions in that row are true. If there is no value in your conditional parameters, that's going to be interpreted as a true value. So blank cells in your conditions are going to result in a true value. Now, if there was an actual blank cell in your returner action column, then that's actually just going to be ignored. And these last 2 points here for rule processing are describing what happens when you have a decision table that only produces a return value, or a decision table which performs actions as well as returns a value. So for a decision table that is only going to return some type of value, processing is actually going to stop after OpenL finds a rule row where all the conditions are true and there's an associated return value. It's just going to return that, stop processing. If there's any more rows with other conditions, it's not even going to execute them or know that they're there or anything. So you're not going to get any other further processing from that table. Not listed on here is if you had a decision table that only actually had an action column, and we didn't really talk about actions, but they perform some type of processing when all of the conditions are met. But if you just had an action column, OpenL Tablets actually will go through each rule row to see if they result in all true conditions met, and those that do have all true conditions will execute the whatever's in the action column, and it'll go through any action column. It doesn't stop processing like when a return value or you have a return column. There's also this third situation, which is listed down here, is when you have both an action column and a return column. But what's going to happen is OpenL is going to stop processing after it finds conditions that result in true and there's a return value in the return column. It'll keep on going if it finds conditions that are true and the return value is blank, but it's good to note that processing will stop when it finds conditions that are true and a return value in its column, associated column. But that means that all the actions in that decision table will not process like they might if you only had an action column in your decision table. It is really so important that you understand rule syntax. Here is another overview that gives you a description of each piece of syntax and how OpenL is expecting your table to be designed. If you are going to be writing rules, you should pause this video and read through this slide. So another type of table that we have is the simple lookup table, and this returns a value associated with conditions that result in a true match. And we've talked about this before. OpenL is going to check each of the condition values to see if it's equal to the input parameters. It works the same as the SimpleRules table, but it uses this horizontal conditional row for validating instead of just always having vertical tables that define your conditions and your return value. You have your initial first column is going to have your condition, and then you're going to have your secondary condition along the second row, which is the horizontal row, and then you're going to have all of your return values in their associated cells. So this table just provides you with maybe a more readable format, or maybe a format that you prefer when creating some type of lookup or conditional match type of rule. Now we're going to demonstrate a simple lookup table. Again, I'm going to use the tutorials found on the OpenL Tablets website, and in tutorial 1, Intro to Decision Tables, we have an example of a SimpleRules table. I will search by type, and I'll expand the decision folder, and then I'll go to the table called Car Price. This is a simple lookup table. You'll notice simple lookup keyword, double value is returned. The name of this table is Car Price. The name is here, and you can also see the name here that we sort through. Then we have some parameters which have been defined: country, which is a string, car brand, which is a string, and then car model, which is a string. So we have country as our first conditional column that was created. And the values that can be entered for country are USA, Great Britain, Lithuania, and so forth. Then we have other conditions. We have the car brand, we have BMW, and we have Porsche. But then we also have the car model. Now we have two models for one car brand, as you can see, both for BMW and for Porsche. For BMW, we have the Z4 S-Drive 35i and the Z4 S-Drive 28i. So I'm actually going to show a demonstration of what happens when you run this rule or this simple lookup table. I can, in Web Studio, select the Run button, and then it's going to ask what country do I want to test. I'm actually running a test right now, and I'm going to say, okay, well, USA, and then what car brand, and I'll just say BMW, and then it'll ask me what car model. And remember, these are all the parameters, and I'll actually paste in the Z4, and then I'm going to hit the return key on my keyboard. It's going to actually run that data as parameter, and it's going to give me a result. And you can see that my result is 55,150. And you can actually drill down and get further into the information of how this was calculated. And you can see it will bring you back to the table that it used to find your result. I'll X out of that extra window that opened up. I'll go back to car price. So I just ran one set of data through here. You could also create a new test table and fill in that test table with the parameters that this table is looking for. But we're not going to do that. Just you need to know that is here. So what we've seen is an example of a simple lookup table.